I'm presenting on context, but I'm also presenting on collection data and social justice, which has quite a big association, and also on the impact of collection systems and traditional databases, particularly commercial databases, on this aspect of context. So this presentation is about bias and issues of diversity in collection data and the contributions that collection systems and associated digital research systems have on these problems. There are many reasons why this bias occurs, despite the claim of neutrality. The Andrew W. Mellon Foundation has pointed out in their surveys issues of demographics in terms of those employed in cultural heritage organisations, and in the artists and works that are selected and presented. Bias is also linked to issues of language, of breadth of expertise and experience, broader discrimination, and in the resources given to researching different parts of the collection. However, this presentation has a focus on form and structure of the collection system model itself and how its structure contributes and perpetuates bias and lack of diversity. The narrowness of documentation, its static and dated nature, its lack of a two-way dialogue, its absence of historical context, its failure to link across time, and crucially, its authoritative stance, which excludes other vantage points and other supportable knowledges. This is an aspect not commonly considered, but it has a considerable effect on the way in which cultural heritage is represented in a data form, significantly impacted by commercial software. The limitations and inherent narrowness of collection data systems is a crucial question, since what we previously hid in internal systems supporting internal processes is now used for public communication, exposing historical, gender, cultural, and racial bias from the back office into the public domain. And therefore, it's not simply a technical problem, but an organizational one which requires new approaches. This tool illustrates and allows for complexity. It's not deterministic, and it allows researchers and cultural heritage experts to assert contextualizing information, whether that be of other historical events, ideas, arguments, influences, and so on. This is one of a number of different tools which could only have been designed by cultural heritage experts themselves. They're designed to put the thinking and the knowledge back into cultural heritage documentation. And there are no differences with current systems in terms of efficiency of processing. It provides better search and discovery by using a conceptual framework, with richer results and better digital preservation of knowledge that is independent of the software. In fact, it reduces overhead by reducing fragmentation caused by the gap that collection systems impose. The ability to include information that is historically relevant, to allow a collaboration of different viewpoints or vantage points, to combine the qualitative with the quantitative, to explore the different parts of histories of an object in relation to other objects, technologies, modes of production, periods, events, social relations, and the concepts of the mind. It saves data with contextual relationships. It does not simply technically link URIs of legacy data. It provides data narrative and a query mechanism that better reflects the questions that people want to ask and contribute to across different heterogeneous data sets. And we'll come back to a demonstration of this. The philosopher Andrew Feinberg, in developing a theory of instrumentation, shows how the process of knowledge generation is reduced by the constraints of conforming to instrumental and institutional frameworks. Computer systems, because they are based on processes determined by technologists and developers, are underdetermined by a fixation on efficiency and responsiveness that, particularly in the current generation of standard computers, is completely unnecessary. We can have representation that is far closer to the way we as humans abstract and understand information with no practical technical issues. The problem is that commercial software houses have no understanding of how these abstractions work or how to support them. They can only predetermine using commercial patterns of representation. They are not subject experts, so they provide systems that conform to their own knowledge systems and business models, not the knowledge systems of their users, who simply accept this as a natural limitation of computers. The cultural heritage community is now more than capable of producing systems that do exactly what these software companies cannot do: represent ideas, provide rich contextualized interconnections across disciplinary areas, compare and resolve issues of different knowledges, and allow computers to help solve complex problems. These systems will not come from the software houses. They will come from the community when we have unattached ourselves from the tendency to attend to their needs rather than our own. I want to use history to illustrate how computer databases have impeded the progress of knowledges. Different knowledges are potentially part of a whole, and in rejecting traditional Western approaches of scientific truth, parts can be combined to provide a better type of objectivity. Western bias in online data resources preserves old ways of looking at and describing concepts. Note that many people mentioned in the slides with a data card are commonly referred to as the father of. This is a common term, often referring to Western men. Francis Bacon himself rejected the idea that knowledge stopped at the pillars of Hercules, the rocks of Gibraltar, and that other knowledges existed that could be developed. The ordering and preservation of past knowledge was the preoccupation of the medieval era, static knowledge. I present the static data cards in Wikipedia to tell you almost nothing important about Francis Bacon. But Bacon was all about expanding the framework of new discovery and new contextual categories.
Just to make this point about preservation of old knowledge more apparent, here we have data from Wikidata based on a query on a field that records who influences who. And as you can see, the field of information shows a historic and traditional view that men are the main influencers. But if we look further, we see women, despite being in positions of disadvantage in comparison to the men of the time, having alternative and perhaps more progressive ideas about knowledge and technology, not least Ada Lovelace, who had a more vision about the potential of computers and whose influence is not recognised in the system.
As the Western world developed ways of exploiting resources, including human ones, the first computers were human. Adam Smith theorised about the generation of wealth and its relationship to value. His two major books, The Theory of Moral Sentiments and The Wealth of Nations, are two parts of an overall whole. While the division of labour was a device for potentially greater productivity and wealth production, which he believed would benefit all classes, rich and poor, Smith also understood that this could have a detrimental effect on people and society, later categorised as alienation, both through the commodification of the labourer and the products that they produced. The product of collection data has the hallmarks of a production line that can alienate. He believed that these effects need to be mitigated by a strong public domain and social framework, a sentiment that has some re-emergence today with issues of modern slavery, environmental damage, and global wealth inequality, issues that are embedded in the cultural heritage objects that we curate. However, his disciples were quick to separate these different considerations, to remove the interconnection between them, and claim they had no inherent dependencies. The father of modern computing, Babbage, was a disciple of one part of Smith's thesis. He wanted to make workers invisible. He saw how to use human computers, originally skilled mathematicians solving questions of astronomy, but they could be further broken down, such that the calculations could be performed by an army of untrained and unskilled workers. But more than this, it was possible to produce a machine that could take over calculations completely. The Astronomy Society, later the Royal Astronomy Society, which included Babbage, was made up of business people, accountants, lawyers, whose interest in astronomy was directly connected to business risk and international trade. Standards are part of the problem. When it comes to intellectual tasks, they provide the ability to claim neutrality and link information. But what they do is remove the need to think when describing data and computer information systems, and are designed to benefit the production of reductive software. In an article by Langmead and et al. In the International Journal of Digital Art History, they said that collection data input has become known as grunt work. To address issues of quality, they suggest the role of data steward to stand over the grunt workers to ensure a reliable transfer of information from source to field. The scene starts to look like a factory line with a shop steward ensuring that the predetermined one-size-fits-all input forms are processed to the factory owner's satisfaction. How can this build knowledge? It is a division of labour that reduces the quality of the output in favour of quantity and limited use value, but it never occurs that it can be any different. That is what technologists have told us. Data input is a non-intellectual task recording non-intellectual information, and in doing so has inbuilt obsolescence. They have, with our assent, pre-programmed the knowledge out of the task. As a humanist, the father of science fiction was more interested in the wealth of education and human knowledge. The answer to many of the world's problems was the integration of knowledge from different parts of the world. Wells foresaw that technology would reduce the distance between people and between the knowledge they communicated to each other. This didn't mean imposing the knowledge of one part of the world onto the other, but to synthesize as a way of improving overall knowledge. It would require collaboration and understanding other ways of knowing. Wikipedia's supposedly neutral stance continues to provide evidence for continuing research into Western bias and international differences. So, for example, Wikipedia's sites in different places in the world have completely different points of view about the same subject. During the computer revolution of the 20th century, even management consultants realized that progression meant a new paradigm to achieve productivity. Instead of top-down management hierarchies, businesses needed to decentralize and utilize the skills and judgment of knowledge workers, encourage creativity, promote continual learning, and an entrepreneurial culture throughout the organization. The type of task management or scientific management developed by Winslow Taylor, Taylorism, and which had been practiced by Babbage, would only impede productivity, stifle innovation, and limit progression. Despite Drucker's logical prediction of a knowledge society, businesses and organizations have been reluctant to loosen the reins and still protect their control of capital and costs, limiting the effectiveness of knowledge workers. Institutional computer systems are still designed to serve management objectives more than users' needs. Despite the lost opportunities and the wasted time servicing and diverting knowledge workers away from more productive pursuits. Artificial intelligence and machine learning are the digital equivalents of Babbage's mechanical automations. To Drucker, computers still had only one task: to provide intelligent humans with raw information they needed to make intelligent decisions. Humans solve complex problems, and the computer's role, and he called computers morons, was limited. However, to people like Doug Engelbart, the father of the mouse and part of the teams that led to the Advanced Research Projects Agency network, ARPANET, providing the foundations for the modern internet, computers could do more than simply provide filter information. They could help people perform increasingly complicated tasks, including ones that involved complex decision-making and digital collaborations. These researchers were not pure computer scientists, but psychologists. For example, they could help humans design complicated buildings, taking into account more interconnected factors that had a bearing on creating the perfect spaces. They could manipulate symbols or lay out complicated arguments. With the ARPANET system, computers could help solve more complex problems by connecting people and knowledges and help them to utilize it. H.G. Wells had much more in common with Engelbart than with Wikipedia. In the meantime, the manufacturers of computers by dominant companies like International Business Machines, IBM, had different design visions based solely on the needs of business. The innovations of the world wars aimed at breaking codes and weapons navigation systems triggered a race to get the first commercial computers to mass market. The focus was to solve business problems, and businesses had no need for systems that dealt with the complexities of historical knowledge. Database systems were not designed to do comparative history, but were designed to process consistent quantities of data quickly for businesses on their terms. Cultural heritage institutions adopted this model without question, confirming to the already established form and structure. They created a single perspective reductive data set. Libraries conform the most because of their particular relationship with the publication industry, but attempts to homogenize museums have been limited and localized, but overall highly damaging to modern digital strategies. The first significant European cultural heritage digital project was RAMA, Remote Access to Museum Archives. It set the tone for all subsequent projects. Regardless of the technology of subsequent projects, the aim was the same: to homogenize data. Even in the age of the semantic web, the same mindset and standards are applied. Ontologies don't reflect the world and its histories. They preserve an old order of artificial vocabularies designed to satisfy the requirements of technologists and costs, not subject experts. Despite the changes in technology mediums, whether client-server, ETL, service-oriented architectures, semantic integration, or data warehousing, the technologists are the modern-day equivalents of the medievalists, seeking to preserve a way of thinking and preventing new ways of knowing. In the 1990s, one of the biggest names in cultural heritage information, David Behrman, founded the Museum and the Web Conference after attempting his own version of RAMA in the United States, concluding that we were going in the wrong direction. Behrman says that increasingly it seems that we should have concerned ourselves with the relationships between objects, not lavish huge attention on standardized vocabularies. Large integration projects wanted to do it all: serve commercial services, educate, provide resources for research, engage with the public. And despite RAMA, Aquel, Mesel, Project Bamboo, Europeana, and many others, all have had very limited success juggling these objectives. RAMA partnered with CIMI, the Consortium of Computer Interchange of Museum Information, initiated by the Museum Computer Network Group. The idea was that they could archive with the same efficient results as libraries. The MARC standard had provided a platform for software companies to create cheaper off-the-shelf systems without any regard for the intellectual aspects of libraries. Publishers and other commercial companies could also exchange book records, but users were left with systems that had no understanding of the intellectual interconnections of the books themselves, particularly across disciplines. Schnapp and Battle's The Library Beyond the Book, they say, the stack itself offers seemingly limitless opportunities for the prepared mind to find conjunctions and synchronicities or wander productively, and yet those possible conjunctions among the books, however vast in number, are limited, not only by the size of the library, but by the catalogue, by whatever ordering principle determines which books stand next to another on the shelves. Digital systems potentially provide, through books, an interconnected map of the history and ideas of the world, but instead we get a map which is, in their words, a tattered ruin. In the 1990s, an article at MIT by Howard Shrove and Peter Solovitz showed how computers could help with human reasoning, inference, and collaboration using a common conceptual reference based on the real world, which could be understood by humans and computers. By sharing a universal but expansive language that everybody understood, human users could explore more complicated relationships between different aspects of the world that the computer could follow, and point out new knowledge that was too complicated for the user to see themselves. It could even understand things that were not all uniform and belonged to different categories at the same time, just like the real world. It could support fuzziness and more natural questions. In the software development world, developers started to dismiss real-world ontologies. They said they were getting in the way of putting raw information on the web, regardless of whether it was interpretable. In reality, it would have meant greater collaboration and a change in the way that developers worked. But they just wanted to get on with playing with the new technology. As a result, linked data failed to come anywhere near its potential, and even Tim Berners-Lee has started again on the web of data. Commercial collection system suppliers could simply stand back and watch. In reality, some ontological frameworks were needed to work with linked data, and developers who have engaged with it have simply transferred existing artificial vocabularies into an ontological form and have not engaged with knowledge representation or new thinking. The notion of conceptual reference was not an invention of the C.CRM. It was a term used in cultural heritage to describe how curators, archivists, librarians combine the two aspects of their work, the physical aspects and the intellectual or external contextual aspects. For example, when we research an exhibition, we do not have a list of objects lined up in a row according to some arbitrary category. They are arranged to answer questions, provide a narrative, to make connections to ideas, places, and people outside the confines of the institutional walls. Publishing legacy catalogue data to the public works against this. Collection, archival, and library systems effectively broke the link between the basic physical and administrative arrangements and essential intellectual processes, as part of a general widening of the gap between different directorates. However, the administrative side of cultural heritage organisations have realised that this division has created a problem as new calls emerge to rectify issues of diversity and bias. Back office processes in the digital age, like documentation, directly affect front office engagement. Organisations have sleepwalked into a digital dilemma. There are knowledge organisations that have digital systems with significant legacy content problems that don't reflect or integrate internal knowledge let alone support other knowledges. As such, there are now many organisations that have initiated operational projects to remedy the problem, but they rely on the very same suppliers and commercial systems that harbour this inherent problem. This includes looking at the possibilities of linked data where exactly the same split has taken place between the technologists who promote a technical linked data and the subject experts who assert the richer ontological commitments. As such, linked data, again starting with the libraries, has started to replicate this division. As such, they are highly unlikely to make more than a ripple in the goal to decolonialise or historically contextualise their data. This can't be done without reuniting all the parts of the conceptual reference and making it more inclusive by supporting community software that breaks the stranglehold of Babbage's invention. So I've just got a few points at the end to conclude. Bottom-up systems that reflect and represent all expertise, both internally and externally. These are the systems that we need. We need an integration of different vantage points, both disciplinary and different social groups. The removal of this IT fixation on efficiency and responsiveness that underdetermines systems and reduces their value. Dynamic systems that are not determined by predetermined vocabulary standards, and greater engagement from academic departments. So I just wanted to skip to a system that we're building. At the beginning of the presentation, I had a slide which showed this model. This is actually an authoring model, so it allows you to add new items to it. This is a model around the artist Doc Frash, and it connects to aspects of his life. So he participated in the First World War. This had a contribution in terms of influencing the civil rights movement. He was part of a movement called social realism, and his work was influenced by a range of different economic factors. And this map has just been created with additional bits being put on as and when the researcher has thought about it. And what that means is that they have no predetermined categories that we need to adhere to. We can simply expand this map however far we want. But because it has a conceptual reference behind it, it will still integrate with all other data that uses the same conceptual reference. So it doesn't matter how heterogeneous it is, it still becomes integratable. So what that means is that we can start doing interesting searches across this data. So for example, I can say I want to search for events that have a societal influence that affected an artist, that influenced an artist like Doc Frash, and see those events. Let me just move that. Look at the data for those events. In this project, Lake Hokusai, we have a requirement to create a semantic map of all of the interesting connections in Hokusai's great picture book of everything. So when we have a look at this, we can do stuff like collect items from our searches and then pull them into an observation system. We can use IIIF not just as a static tool to put annotations in, it actually becomes part of the conceptual reference. So these annotations are actually related to physical features or inscriptions or visual items or conceptual things that then we can then edit. And we can connect across these different things as well. So these annotations can then be connected. So I can go into any one of these and I can fill in some information about it, but I can also say that I want it to refer to another visual item, and I can sort of drag connections in and put them in here. And what that means is that I can create interesting maps of those connections and look at them in a different way. So for example, I can take those two images that I just saw and see the work that I've been doing on them and creating that semantic map. This is another site, it's an archaeological site. And I wanted to say that doesn't get rid of the need sometimes to use forms and input forms. So if I have a look in here, clipboard, go to something called thinking frames. So in here I have different types of information. I have stratigraphic units, and I have archaeological concepts. But even with these, I can drag them into entity editors and automatically generate an input form for them, which can be dynamic. Again, with this physical object, it has a different type of form, so I drag that as a different type of input. And these forms are not linear, they are underlying, they are hierarchical forms. Boxes connect by relationships, so you're actually filling in a semantic form and creating a graph, which then can be visualized in the same way as like the other systems. This is another knowledge graph, and it's illustrating the passing traditions in West Africa. So it's a representation of the traditional passing traditions that we know about, but also ones that we don't know about. It's investigating these objects that are found in different places in West Africa. These are the Deceiving bronzes, which have been a lot of research done by people like William Fagg, Professor Frank Willett. And they have different arguments, and these arguments can be illustrated. So there's inference these people use in terms of social history or symbolism or other arguments that are put forward by other academics. And these arguments then can be expanded and hyperlinked from within the main knowledge map. And you can see the arguments they're trying to make and illustrate them in a little bit more detail. So this one here, for example, is Frank Willett talking about some of the symbolism on some of the objects, these sorts of things which connect them to provenance and places of origin. Again, you can have a look at the data as you go along. And then I realise I haven't got much time left. So if I go back to that, I can obviously put more items into this knowledge map. So I can go into my clipboard, for example, and I can put in a place, and I can connect these things together. I can save this in as a current location of this museum. But also I can generate a completely new piece of information. So I'll play that. So my main point is that it is not impossible to produce systems that are not predetermined and have relationships and hierarchies that are complicated, but still can produce or can be represented in standard computer systems.